Okay, I'm doing the problem now. I'm the student. Determine the load impedance of the line that has an input impedance of 30 minus J100 and the characteristic impedance of 50 and then a length of 3.4. So first let's draw. So we have load here. Okay, so the load impedance we don't know. We know that the input impedance is 30 minus A100 ohms, so that's going to be the impedance of the generator. And this is going to be 30 minus J100. The characteristic impedance is going to be it's going to be 50 ohms, and then the length of the line is going to be 3/4 lambda. So now let's go. So normally we plot the load impedance, but since we don't have it, we plot the input impedance. So to plot the input impedance, you divide by 50 first. Zin divided by ZO.
Why do we divide by 50?
Because ZO is 50. So you divide by ZO.
But why is that? Why characteristic impedance?
Because it says it on the circle. Then you take the resistance, you divide it by ZO.
Also erase this. Like erase the whole page.
So after we divide by ZO, divided by 50, so you get 3/5 minus 2. Okay, 3/5 is 0.6. Okay. So, sorry, not ohm, because we divide ohms over ohms, so they cancel out. So I look for 0.6. So right here, and now look for 2. So 0.6, and then 2 is right here.
Minus 2 is over there.
Minus 2. So it's going to be along this line. Minus 2 right here. So now we draw a straight line. Go from here all the way till here. There we go. And now we draw the circle. There we go. Close enough. And now draw the circle. There you go. Oh, shoot.
That's good enough.
Okay, that looks good enough. So now, what do we have to find? We have to find a load impedance. So first, let me just extend this line. And the reason I extend it is to find lambda. So lambda is towards generator.
Towards the generator or towards the load?
This time we have the load impedance.
The input impedance.
The input impedance. So we are going from the input impedance towards the load. So we're actually going this way now, right here, this way. We're going on the second line, which is towards the load. So we're looking at the bottom value. The bottom value right here is going to be 0.181. Looks like it. Yeah. This is 0.18, 0.2, something like that. Lambda. So now we found the lambda here, and now we have the length of 3/4 lambda. So 3/4 lambda is going to be, so this is going to be 0.181 plus 3/4 is 0.75. You get 0.931. So now this is above 0.5 lambda, meaning you subtract 0.5 lambda. So it's going to be 0.931 minus 0.5. You get.
Why do we subtract 0.5 lambda?
Because the highest value of lambda in this graph is 0.5. So it can only go up to 0.5, and so that means it's just gonna loop around again like this.
Yeah, that's how. It's kind of like 360 degrees. You subtract.
Yeah, it's kind of like polar coordinates. Yeah, so it's like, polar coordinates. This is like 360 degrees, and this is like you just loop back again to whatever point you were at. So when you do that, you get 0.431. So I'm gonna go to right here. This 0.431 right here. No, sorry, that's the wrong side. That's towards generator. We're going towards load. So that would be right here. 0.431. And so now I draw a new line from the center. So I draw a line from the center all the way here. It's close enough. It's close enough.
Yeah. Yeah, it's close enough.
Yeah. And then so now I look at the reservoir circle. I can see that it lines up right here. Right. So this point right here, we do go down the circle. We go down this line. So this line right here is gonna be. It's gonna be. Oh, you erased the circle. You're not following the circle, you're following the line. So you're following this line right here. This line breaks off from the circle right there. It continues down right here. So this line right here is 0.14. And then the impedance is going to be 0.4. So 424446. This is 0.46 and it's positive. So now
it's G.
J. So now I write here 0.14 plus 0.46J. And now since I divided by 50, I multiply by 50. And so I will get 7 plus 23J. So obviously you will get a more better value based on how well you draw. I mean, I was slightly off, so maybe it could be like 0.45 and then you multiply by 50. But it's I mean, for me it's close enough, but if the professor wants more accuracy, then obviously do a better job at drawing. And this is now going to be our ZL is equal to 7 plus 23J ohms.
Yeah, that's
That's our final answer.